Hi everyone. Today in this lecture we will discuss rules for differentiation. So when we discuss these rules for differentiation, so that means you can also say that how the operations takes place as far as the differentiation is concerned. The addition, subtraction, multiplication, what happens when we differentiate a function and we have to add them or subtract them, divide them, multiply them and all that. So let us see this. So here you can see d by dx, this is differentiation of constant. So differentiation of constant, this you can also write like this. Y is equal to suppose some constant c. So we have to calculate the differentiation of this constant. So we will write dy upon this dx, it is equal to 0, because differentiation of constant it is 0. And why it is 0? Because it is cx to the power 0. We can write this as cx to the power 0. When it is x to the power 0, and we know differentiation of x to the power n, it is n x to the power n minus 1. So here it will be 0 into x to the power 0 minus 1. 0 into something, that becomes 0. So this part it will become 0. And that's why we say differentiation of y with respect to x when y is equal to c, where c is a constant, it is 0. So that's what we can represent. Now here you can see this representation, d by dx of c. This is same as this, d by of dx. Here we have assumed y is equal to c. So already y is a function of x, but here it is a constant term. So these things can also be represented. This we can also represent directly as of dx, yani differentiation of c with respect to x. Differentiation of y with respect to x, but here y is equal to what? C, means differentiation of c with respect to x. So that's the way that we also represent the differentiation of one quantity with respect to the another quantity. Similarly, does it say what happens if a variable, because when we consider this u, suppose u is a function of x and v is also a function of, because in this we have assumed u as well as v. U is a function of x and v is also a function of x, both depends on x. So we can consider y is equal to ux plus this vx. We can consider ux minus vx. We can consider ux into vx and so on. Just for example, you can say y is equal to sin x plus cos x. So if sin x can be represented as ux, then this cos x it is represented as vx. So sin x it is a function of x, so we can represent it as ux. Cos x it is a function of x, so we can represent it as vx. So we have this y is equal to sin x plus cos x. We can take sin x minus cos x. We can take sin x into cos x. We can take sin x upon cos x. So that way. So these are the two different functions. U is a function of x and v is a function of x. So those are two different functions of x. But what is y? Y is a function of x, which is combination of these two functions, ux as well as vx. Either combination is in the form of addition, subtraction, multiplication or division. So y is a function of x, where y again it is a function of x and it is combination of two different functions, u as well as v, which is also function of x. That is the meaning when we say ux, vx and y is equal to this plus this minus this into this, or this divided by this. So now let us consider this. So if you see here, u is a function of x, but is it multiplied by some constant c. So this property say, or this rule say, when a function is multiplied by some constant c, the differentiated part gets multiplied by c. The differentiation of u, it will be how much? Du upon dx. Differentiation of y with respect to x, it is dy by dx. Differentiation of u with respect to x, it will be du by dx. Differentiation of v with respect to x, it will be dv by dx. So when a function is multiplied by some constant c, then the differentiated part of that function gets multiplied by c. So differentiated part of this function u, it is du upon dx, and it is multiplied by this constant c. So that is the significance as far as, and why it happens, that also we can see. So if you have suppose some constant y is equal to cx, Let us say y is equal to cx. So here again you can consider this is cx to the power 1. So dy by dx, it will be equal to how much? C into x to the power 1 differentiation. So that is 1 into x power 1 minus 1, 1 minus 1, that is 0, x to the power 0, that becomes 1. So it is finally 1. So here it becomes c. Okay. So this is the way. Now c, there is no change in this constant c. So we can just generalize this. You can consider cx square. If y is equal to cx square, then dy by dx, it will be equal to how much? C into differentiation of 2x, so x square, that is 2x, so twice of this cx. So here there is no effect as far as this c is concerned. That remains as it is. Only when c is independent of any function, then differentiation of a constant, it becomes 0. But if it is with some constant, that differentiated part of that function gets multiplied by the constant c. So this is the meaning of this one. Similarly here you can say, if you have to differentiate the sum of the two functions, u is a function of x and v is a function of x. So if we have to differentiate the sum of the two functions, suppose y is equal to ux plus vx. Okay, y is equal to ux plus vx. Yani y is sum of the two functions and both the functions are functions of x. Then dy by dx, it will be equal to differentiation of this function plus differentiation. So you can write dux with respect to x plus dvx with respect to this x. Okay, so this way we can represent. Now here so many parameters we have used. U is a function of x, v is a function of x. So we can speak like this, but once it is understood that u is a function of x, v is a function of x, so there is no need to always pronounce like this. We can directly say u is a function of x, v is a function of x. It means differentiation of some of these two functions, it will be sum of the two differentiation. So sum of the two differentiation of two different function. So du upon dx plus dv upon dx. Du upon dx, it is same as this. I have just made that x silent here. So it is du upon dx plus this dv upon dx. So these are the ways that you can represent. Similarly, u minus v, the subtraction of the two functions. So it will be same as the subtraction of the two differentiated functions. So it is du upon dx minus dv upon dx. It means, just to get the clarity, if there are sum of two functions, just differentiate them separately and add them. If there is subtraction of two functions, differentiate them separately and subtract them. Similarly, we can see for the multiplication as well as division. So here if you see this product of the differentiation of the product of the two functions, that is, if y is equal to, suppose, ux into vx, y is the product of the two different functions. U is a function of x, again v is a function. Then what happens? So we can write dy upon this dx is equal to, if this is suppose your first function and this is suppose second function, then you can say first means ux into differentiation of this. Okay, ux into differentiation of this plus vx into differentiation of this. So it is dux on dx. ux into differentiation of the second function, that is v as a function of x with respect to x, plus the second means the vx into differentiation of first, yani du upon dx. When I say du means d where u is a function of x, so du upon dx. So that way we can calculate. This is what it is written in this relation, d of dx uv, product of the two. So it is u into differentiation of the second, dv upon dx. So it is dv upon dx plus second v into differentiation of the first, that is du upon dx. So it becomes your du upon dx. So that way we can do as far as the product of the two functions are concerned, u into dv upon dx plus v into du upon dx. That's what we have to do whenever you have the product of the two terms or product of the two functions. Now let us consider what happens when one function is divided by the another. Means if we have to differentiate ux divided by vx, if you have to calculate the differentiation of u by v. So again here, if it is suppose y is equal to ux divided by vx. So if we have this relation, then the standard relation is to differentiate term in the denominator, that is vx, into differentiation of term in the numerator. So it is differentiation of ux minus term in the numerator, that is ux, into differentiation of the term in the denominator. So this becomes this. Divided by this whole divided by denominator square. So it becomes terms in the denominator square. So this is the differentiation of u by v. Y is equal to ux upon vx. So we will have y is equal to vx dot d ux upon dx minus ux dot d vx upon dx. D means differentiation of vx upon dx divided by vx square. Now the first function, when I say ux or vx, that ux may be a constant, vx may be a constant, it may be a function of x, it may be a constant. The rule will remain same. Here, because if it is a constant, only thing is whenever we will differentiate that constant, it will become 0. Otherwise, all relation and everything, the concept behind this, it will remain same. So let us see few examples based on the rules of differentiation. So here if you see the first example, so this is y is equal to x to the power 4 plus 4x cube plus 5x minus 6. So we have to find dy by dx. So here orally we can tell the answer of this. X to the power 4, using the concept of x to the power n, y is equal to x to the power n, so dy by dx equal to n x to the power n minus 1. That n has to be a constant, it can't be variable. That always you have to keep in constant. So you keep in mind. So you have this x to the power 4, so differentiation will be what? 4x cube. 4x cube. So differentiation will be what? 4 into x cube differentiation, that is 3x square. So 4 into 3x square, that becomes 12x square. 5x. So differentiation of x, it will be 1, so it becomes 5. Minus 6. 6 is constant, so that differentiation of 6, it will be 0. So here you can see. First let me see this relation. So 4x cube plus 4 into 3x square plus 5 into 1, because differentiation of x it is 1, and minus this 0 because differentiation of constant it will be 0. So this is our answer. Now why these steps? This is just for your understanding, because you have started the subject, so this is just for your understanding how to elaborate terms, how to differentiate one by one. But once you start learning, you can ignore all this. Directly you can come and you can get this answer. Now see how we have arranged. We have dy by dx means what? Differentiation of this term plus differentiation of this term, differentiation of this and differentiation of this. It means we are using the concept of what? Differentiation of u plus v is differentiation of u plus differentiation of v. That's the concept that we are using here. So this means differentiation of this entire function means differentiation of this term separately, differentiation of this separately. You can see this dx power 4 upon dx. Here it is d, again 4x cube dx, d of dx 5x minus d of dx is constant 6. So it is just as we have discussed u plus v or u minus v. So we have separated each and every term. Wherever there is addition, we will have the differentiation of the added term, otherwise it is, if it is subtraction, you will have the subtraction. Now separately differentiate it. 4. Now here we have used the concept of what? Differentiation of c into u. It will be equal to c into differentiation of u. So c here it is how much? Constant, that is 4. So 4 differentiation of this u, because u is a function of x. So we have, just for your understanding, we have separated and we have mentioned each and every term. Once you learn, you don't have to do so many things. As far as the calculation part is concerned, directly we know differentiation of x power 4, it is 4x cubed. We will write this 4x cubed. Next it is 4x cubed here, and this is x to the power 4, so 4x cubed. Here it is x cubed, so it will be 3x square, so 4 into 3x square, and so on. And we can get this answer. I hope this is clear. So let us see the next example. Now see here we have this function y is equal to 2 sine square x plus 3 cos x minus 1 upon sine x. Again, there are so many terms in the numerator and there is a single term in the denominator. So before simplifying, we can make use of algebraic operation here, numerator upon denominator. So we will consider differentiation of this divided by this plus differentiation of this divided by this minus differentiation of this divided by this minus 1 upon this. So differentiation. So we can separate the term, and again we can use up the rules of differentiation for added function, subtracted function, multiplied function, or the divided function. So that's what we are trying to make out as far as this question is concerned. So 2 sine square x upon sine, you can also say, why not keep it in the u by v form, and you can do it, because if it is suppose u and this is v, then you can say that our problem is in this form, ux divided by vx. We can directly use that relation, v into differentiation of u du upon this dx, a minus u into dv upon this dx divided by v square. This also we can use, but we have to see the simplicity of the steps that we will be following, whether this method will be simpler or this method will be simpler. So that will be again your choice. If you feel that this will give you lesser calculation and this will give you complicated calculation, then obviously we will prefer this. So this is just a preference, whether I should use this or this. That preference depends on which method gives me the easier calculation and the easier solution. So we can use this method, we can use this method, that is, there is nothing wrong in using this. But we feel that this method may give me a complicated solution or complicated step, then why should I go for this? I will simplify this and then separately I will differentiate each and every term. So that's what we are trying to do. So 2 sine square x upon sine x, that will simply be 2 sine x. So you have this 2 sine x. 3 cos x upon sine x, that will be cot x. 1 upon sine x cosec x. Now these are in the standard formula. We have differentiation of sine x, directly we can use that. We have differentiation of cot x, we have differentiation of cosec x, we have the formulas for it, and directly we can make use of those relations. So this becomes again your c into u. C will be taken out and you will only be differentiation to 2 sine x, that will be 2 into differentiation of sine x, so 2 into differentiation of sine x. 3 cot x means 3 into differentiation of cot x. Here it is only minus of 1 cos x to minus of this cosec x. Now these are in the standard form. Use the formulas directly, substitute the value and calculate it. Sin x, that becomes your cos x. Differentiation of cot x, it is minus of cosec square x, that we know from the standard relation, and cosec x, it is minus of cosec x into cot x. Substitute, simplify, and you will get this value. So this way we can consider. So you can make use of the different rules of differentiation as far as the addition of the function, subtraction, multiplication, division of the functions are concerned, or any function when it is multiplied by constant. So these are the rules which we will be using. So two things that we will continuously be using, and that will throughout differentiation. The next topic, it will be integration and some of the standard relation that you have to keep in mind, like sin x, cos x, tan x, sec x, all these standard relation. and the rules of differentiation. We know this, only the nature of the question will come. We will apply our mind and we will use which method should be used, which formula should be used, so that we can simplify those questions easily as well as in an effective manner. Because whenever you solve a question, there should always be two intentions in your mind. My steps should be such that I get an easier solution, which will save you time. And steps should be such, the writing should be such, the thought process should be such that I should get the correct answer. Always save your time and try to get the correct answer as soon as possible. So these are the two things that comes from practice, and we will do more and more practice, and that will help you. Thank you.